In September 2024 at IMTS in Chicago, a machine sat in a small corner of the show floor. Its table accelerated on linear rails. Its X and Y axes could rapid at up to 1,200 inches per minute. Its BT30 spindle could spin at 10,000 RPM. The whole system weighed about 2,800 pounds, a fraction of what many industrial vertical machining centers weigh. For a certain kind of engineer, it was exactly the kind of machine that makes you stop walking. Not because it was the largest machine in the hall, not because it was the most powerful, but because it seemed to answer a question that had been hanging over small shops, labs, schools, and garage businesses for decades. What if you needed to make a real part in real metal without buying the infrastructure of a factory? The machine was the Tormach 1500 MX. But the 1500 MX is not where this story begins. It is not even the center of the story. It is the result of 23 years of one company repeatedly opening the door to CNC, then discovering that the people who walked through that door always wanted to go further. To understand why that machine mattered, you have to go back to Wisconsin in 2001, when Jackson and Ed Korn did not yet have a product, did not yet have a user community, and did not yet have a catalog of machines. They only had an idea for what would become the legendary personal CNC 1100. At the time, they were staring at a complaint the machine tool industry did not seem interested in solving. If a person needed to do serious work but did not own a factory, what exactly were they supposed to buy? If you enjoy stories about the companies, people, and decisions that shaped the industrial world, subscribe to the Gear Archive and follow along. In the early 2000s, an engineer who wanted CNC capability in a small workshop usually faced two paths, and both of them came with risk. The first path was the hobby machine, a kit, a conversion, or a small mini-mill fitted with motors and a controller. The entry price was manageable. The power requirements were friendly. The do-it-yourself CNC community was full of people willing to share advice. But the machines were light, the spindles were small, the travel was limited, the build quality varied. A machine that was supposed to help finish a project could easily become the project itself. The second path was a used industrial machine. At auction, a buyer might find several tons of cast iron, a powerful spindle, and a real industrial tool taper at a price that looked almost impossible to ignore. But the hammer price was not the real price. Behind it came rigging, forklifts, three-phase power or a phase converter, compressed air, floor loading, coolant systems, aging control boards, an unknown spindle history, backup batteries that needed replacing, and a service model built for companies with maintenance departments. A bargain could become the best machine in the shop if the buyer knew what he was doing. It could also sit dead for months while its new owner hunted for parts. The difference was not just money, it was the ability to absorb risk. A new industrial machine solved many maintenance risks, but created a capital barrier of its own. That was the gap. Factories optimize for the number of good parts produced per hour. Product engineers optimize for the number of design loops they can complete in a week. Jackson and Ed Korn saw that space in between. They were not the first people to build a small CNC machine. Tormach did not invent numerical control. What they recognized was that the industry had allowed the scale of the equipment to decide who counted as a serious customer. If small machines were automatically treated as hobby machines, then professionals doing low-volume work would always be forced to buy either too little machine or too much. Jackson and Korn changed the question. They did not ask how to put the full capability of a production VMC into a garage at a discount price. They asked which parts of that capability determined whether a part was usable, which parts mainly determined speed, and which parts could be purchased later after the need appeared. That question led them to the idea of personal CNC, and that idea led Tormach to the machine that would define the company. Tormach was founded in Wisconsin in 2001 by Greg Jackson and Ed Korn. The two men were friends and both had experience in manufacturing automation. One owned a specialty tooling company. The other was the general manager of a technology research company. Both could have used a small CNC machine for prototypes or specialized production. Both looked at the market and failed to find the machine they actually needed. In their early conversations, they complained about that absence, then began imagining a different kind of machine. They called it personal CNC, intentionally echoing the way the personal computer had brought computing power out of the mainframe room. The personal computer did not need to replace a mainframe in every task to change who could use computing. Personal CNC did not need to beat a VMC in production output to change who could machine metal. The idea might have stayed a conversation if the economy had not forced a turn. The technology recession of 2001 and 2002 pulled investment away from the research company where one of them worked, and the company shut down. Jackson and Korn returned to the personal CNC idea and decided it was time to do more than talk. Tormach began in a garage near Madison, Wisconsin, which matched both the capital available and the experimental stage of the company far better than a large factory would have. Jackson and Korn entered the machine tool business with obvious disadvantages. They had no decades-long history. They had no national dealer network. They could not send technicians into every garage. If the product was only cheaper, it would disappear somewhere between hobby mills and used industrial machines. They needed to design not only the machine, but the way a buyer would own it. That is why the most important part of Tormach's origin story was not a drawing or a first test cut. It was the specification the founders set before the PCNC 1100 existed. That specification showed that they understood something fundamental. A lower price always has to be purchased with a compromise. Success depends on putting the compromise in the right place. The first criterion was that the finished quality of the part could not be sacrificed simply because the machine was smaller. The frame had to be rigid enough. The positioning resolution had to support ordinary machining tolerances. But Jackson and Korn were willing to reduce spindle power and maximum feed speed. Those variables made a program take longer, but they did not necessarily make the part wrong if the machine, tool, fixture, and cutting strategy stayed inside a stable range. That choice defined Tormach. A production VMC is optimized to make many correct parts quickly, hour after hour. A personal CNC machine was optimized so one person could make a correct part with less capital, even if he had to wait longer. The second criterion was price. The machine had to be affordable enough that it did not need to run continuously to justify ownership. A lab might let the machine sit idle for days and still consider it a good investment because its value appeared the moment an engineering team needed to revise a design immediately. Jackson and Korn were not trying to sell factory capacity to people who did not have factory-level workflow. The third criterion was openness and user serviceability. The machine should not require a factory-trained technician for every repair. Parts needed to be obtainable and reasonably priced. For a garage shop, that was independence. For a business owner who only wanted to call service and keep production moving, it could be a burden. Tormach accepted that it would serve the first group better rather than pretending to fit every customer. The fourth criterion was modularity. A fourth axis, coolant, a power drawbar, and an automatic tool changer could be added later. Tooling could be purchased à la carte. A buyer could start with a basic machine, learn from real work, and then use later revenue or budget to expand. Tormach turned one large capital decision into a series of smaller ones. The fifth criterion was logistics. A machine that was affordable but could not fit through a door, required a crane, or forced a complete electrical overhaul was still not truly accessible. A personal CNC had to reduce shipping and installation friction, even when the delivery address was a residence. The machine, stand, and crate design became part of the product. Together, those criteria formed a clear formula. Preserve what lets the user make a usable part, reduce what mainly makes the part finish faster, and make everything not yet necessary optional. After about 2 years of development, Jackson and Ed Korn were ready to find out whether the market agreed. In 2003, Tormach released the PCNC 1100, a machine born from a clear philosophy that would become the most famous product in the company's history. The PCNC 1100 did not become legendary because it was the strongest, fastest, or most accurate machine in the industry. It became legendary because it turned a hard-to-name gap into a visible category. After it appeared, an engineer no longer had to choose between a hobby kit and a vertical machining center. There was now something in the middle, heavy enough to cut metal seriously, small enough for limited space, and cheap enough to own before production volume existed. A 2006 article in American Machinist described the PCNC 1100 with a 34-inch by 9.5-inch table, 17 inches of vertical clearance, and the ability to machine steel, titanium, and stainless alloys. The price was about $6,800. That was a 2006 price, not including every accessory needed for a complete shop, and it cannot be compared directly with today's prices. But it showed the shock Tormach had created, a machine that fit the budgets of individuals and small engineering groups. The PCNC 1100 continued to evolve through several series. Series 3, announced in 2011, used a cast-iron frame, hydrodynamic sliding ways with low-friction surfaces, an R8 spindle running around 5,100 RPM, and a motor rated at 1.5 horsepower. Travel was about 18 inches in X, 9.5 inches in Y, and 16.5 inches in Z. The main power used single-phase 200 to 250 volts, while the controller and coolant system used 115 volts. Those numbers reveal both the capability and the limitation. The travel was enough for prototypes, fixtures, vehicle accessories, robot parts, and many small commercial products. The cast-iron frame and greater weight gave it more resistance to cutting forces than a benchtop machine. The R8 spindle made tooling accessible, but 1.5 horsepower is not a 10 or 20 horsepower spindle. Rapid moves were not VMC rapid moves. A modular machine did not automatically include the chip management, automatic tool changing, and full enclosure of a production cell. The difference was in the kind of time the user wanted to save. A PCNC 1100 might take longer to cut apart, but it eliminated quoting time, shipping time, and outside shop scheduling. An engineer could discover that a hole was in the wrong place, fix the CAD model, regenerate tool paths, and run the next version the same day. The machine could be slower by the minute and still make the project faster by the week. The PCNC 1100 also let users buy capability with skill, sharp tools, short stickout, rigid fixturing, steady tool engagement, and conservative feeds allowed the machine to cut steel and difficult materials. The operator could measure, compensate offsets, and refine the process. Tormach did not remove the cost. It shifted part of the cost from capital into learning and owner involvement. That is why the machine produced such a strong emotional response. To a machinist used to standing in front of a multi-ton VMC, it could look like a bundle of compromises. To someone who previously had no machine at all, it was autonomy. Both views were correct in their own context. The PCNC 1100 became the foundation for Tormach's later product line. But before the company could expand, Jackson and Korn had to solve a harder problem than hardware. A new machine buyer still did not have tooling, work holding, software, knowledge, or confidence. If Tormach simply delivered a block of cast iron and walked away, personal CNC would still be a machinery project. The price of the machine body is only the first number in CNC ownership. A buyer still needs a stand, an enclosure, CAM software, power, and sometimes compressed air. They need to move the machine into place, level it, set work offsets, enter tool lengths, and create a program that does not drive a cutter into the fixture. A cheap product that forces every customer to reinvent the entire process cannot grow far beyond experts. Tormach built a catalog of tooling, work holding, and accessories around the PCNC 1100. Buyers could source the mill, coolant, power drawbar, automatic tool changer, rotary axis, probe, and many of the necessary shop components from the same ecosystem. The a la carte structure kept the first step affordable, but it also revealed an important truth. The advertised base price of the machine was not the cost of a complete cell. The company also chose direct sales. Direct sales removed a layer of cost and fit the internet age. But it also meant customers did not always have a nearby dealer and technician, the way they might with a larger industrial builder. Manuals, schematics, spare parts, and user serviceability were not secondary after-sale services. They were required by the business model itself. Logistics became a feature. Tormach documentation explained how to move a PCNC through a doorway, install a stand, and handle the machine in a small address. A user could trade a weekend of labor for lower rigging costs. For an individual with skill and time, that was an advantage. For a shop with orders waiting, the installation time might cost more than hiring professionals. Growth, however, pulled Tormach beyond the customers willing to tolerate every inconvenience. The PCNC 1100 proved that a small machine could do real work. Now buyers began asking a different question. Could it do that work fast enough, consistently enough, and long enough for someone to bet a livelihood on it? In 2011, Tormach introduced both the PCNC 1100 Series 3 and the smaller PCNC 770. The PCNC 770 ran on 110-volt power, had a smaller footprint, and carried a base price of $6,400. It lowered the entry point into CNC again, especially for home shops that could not easily arrange 230-volt power or did not have room for the 1100. Wired gave the machine an 8 out of 10, praising the price, modularity, household power capability, and online and phone support. But the review also noted that its 1-horsepower motor was weak compared with a 7.5 horsepower industrial machine. It recorded that tolerances in the test could vary by as much as 0.002 inch between days. That review touched the debate that had followed Tormach from the beginning. A machine can make useful parts and still not be the right machine for production. It can cut steel, and it can cut steel profitably at high volume, are two different statements. If a PCNC finishes a part in 40 minutes and a VMC finishes it in 15, the difference barely matters for two prototypes. For 10,000 parts, it becomes thousands of spindle hours, extra labor, and delivery risk. A low purchase price only becomes an advantage when volume, margin, and the value of flexibility line up. Those criticisms did not prove Jackson and Korn had chosen wrong. They proved the opposite. Personal CNC had succeeded so well that users were now pushing the machines into jobs beyond the original specification. Tormach had been clear that the PCNC was intended for R&D, product development, and light production, not as a replacement for full production capability. The most important tension in Tormach's history was not a rise and collapse in sales. It was that the company's credibility grew until its machines were judged by a harsher standard. Tormach had to preserve accessibility while narrowing the gap between someone buying a machine and someone operating CNC effectively. The biggest answer would not be more cast iron. It would be software. Early Tormach machines used Mach 3, a control platform familiar to the die CNC community. It helped the company move quickly without developing every layer from scratch. But as the installed base grew, every variation in computer, driver, plug-in, and configuration became a support variable. PathPilot was Tormach's move to take control of the user experience. The control system was developed on a platform sharing code with Linux CNC, then extended with Tormach's own interface and machine-specific features. It supported industrial-style G-code, conversational programming, probing, tool tables, work offsets, tool path preview, and other capabilities depending on the machine. The value of PathPilot was not only its features. For new users, a consistent operating flow turned CNC from a collection of intimidating codes into a learnable process. Reference the axes, locate the work, enter tools, load the program, check the tool path, and adjust the feed. For Tormach, one control across mills, lathes, routers, and later robots meant documentation, videos, support, and user knowledge could be reused. PathPilot did not transform the hardware into a different machine. It did not make the spindle stronger or the frame heavier, but a control that reduces setup time and operator errors can create more value than a small increase in speed. On an inexpensive machine, an extra hour of setup can quickly become expensive. On a moderate machine with a clear operating process, real productivity can exceed expectations. At the same time, YouTube became Tormach's largest showroom. The company matured at exactly the moment when buyers began watching cutting videos, setup demonstrations, and reviews before ordering a machine. A small manufacturer no longer had to bring a demo to every city. It could show viewers steel chips, a probe finding a corner, a rotary axis cutting multiple faces, and a commercial part coming out of a vise. Users made content as well. John Saunders documented his journey learning CNC and building Saunders Machine Works on NIC CNC, putting Tormach in front of thousands of people who wanted to begin. Saunders later became a brand ambassador, so commercially connected content has to be separated from independent reviews. But the larger phenomenon was bigger than one person. Schools, makerspaces, FIRST robotics teams, and countless owners created a library of knowledge that no advertising campaign could easily buy. Video can prove that a machine cuts material. It does not prove the economics. A 3-minute clip does not show setup time, broken tools, failed attempts, tolerance drift after 8 hours, or cycle time against competition. A showroom built from chips is only reliable when the viewer compares it with specifications, manuals, independent reviews, and work that resembles their own. In education, the ecosystem was especially powerful. Smaller machines allowed more students to get hands-on time. PathPilot reduced the learning curve of the interface. Videos let students prepare before lab. Tormach supported FIRST robotics and placed machines in high schools, technical colleges, and universities. Every student who learned on that control became someone who could carry the workflow into a later project. By this point, Tormach was no longer just selling the PCNC 1100. It was selling machines, controls, tooling, content, and community as a complete path into CNC. Jackson and Korn had created a flywheel, but succession now became the next question. How does a company built around the philosophy of two founders preserve that philosophy when the products, employees, and customers all grow larger? In 2014, Tormach became 100% employee-owned through an ESOP. An ESOP does not mean every employee votes on every product. It does not guarantee good decisions. It is an ownership and economic benefit structure in which employees have a stake tied to the long-term value of the company. For a manufacturer whose model depended on support and user serviceability, employee ownership fit the brand story. But culture does not replace strategy. Tormach still needed to grow, and growth often pulls a company away from the model that made its name. The catalog expanded downward to the PCNC 440 and XST, across to the PCNC 770, into the 15L and 8L lathes, the 24R router, saws, rotary products, and a widening range of accessories. Each product could reuse PathPilot, the sales channel, and the community. A school that trusted a Tormach mill could buy a Tormach lathe. A garage business that needed milling and turning could stay in the ecosystem. But every model also created a long-term obligation. Machine tools are not consumer devices replaced after 2 years. Owners need manuals, parts, firmware, and support for decades. A small company that expands too broadly can end up dividing engineers between new product development and maintenance of the installed base. Breadth creates revenue, but it can thin out depth. This path was different from other American machine tool stories. Fadal, for example, was sold by its founding family near the height of its growth, after which the brand passed through multiple owners and gradually lost influence. Haas has maintained concentrated authority around Gene Haas, which creates continuity but also concentrates risk when the founder becomes legally entangled. Tormach moved economic ownership to employees. It is impossible to say which model is inherently better, but Tormach's approach reduced the degree to which the company's survival and product quality depended on the founders themselves. After the ESOP, Tormach did not freeze around the PCNC 1100. It continued developing more spindle speed, servos, automatic tool changing, and automation pushed Tormach closer to the industrial side of the market. Every step also increased price and complexity. The tension between the legacy of Jackson and Korn and the ambitions of the customers became clearer. In 2018, Tormach introduced the 770M and 1100M after more than 2 years of development. The stand and enclosure were redesigned for better chip management. The spindle became more powerful. Accessories became more plug-and-play. The 1100M gained additional Y-axis travel and a 7,500 RPM spindle. In late 2019, the 770MX and 1100MX pushed further. Servos replaced steppers on all 3 axes. The spindle moved to BT30 with an encoder for rigid tapping. Maximum spindle speed reached 10,000 RPM. Rapid travel speeds increased substantially. These were direct answers to many of the PCNC's old limitations: slow motion, R8's limits with professional automatic tool changing, and the absence of spindle orientation. Prices rose. The number of subsystems that required maintenance rose. Air and infrastructure needs increased. Buyers began comparing Tormach not only with hobby machines, but with used VMCs. In 2022, Tormach carried its accessibility philosophy into robotics with the ZA6. The 6-axis arm offered a 6-kilogram payload, 975 millimeter reach, EtherCAT servos, single-phase 220-volt power, and a published price below $20,000. Tormach used Python inside the PathPilot environment, aiming at engineers who might not be familiar with traditional industrial robot systems. But the robot exposed a new limit in the promise of accessibility. The arm is only one part of a cell. The user still needs a gripper, fixtures, guarding, an automatic door, I/O, part feeding, chip management, inspection, and recovery logic when something fails. Tormach could lower the first step. It could not erase system integration. Then came the 1500 MX in 2024. With travel of 19.7 by 13.8 by 14 inches, a 10,000 RPM BT30 spindle, 4 continuous horsepower, absolute encoder servos, and X and Y rapid speeds of 1,200 IPM, the machine moved Tormach into a new performance range. It still used single-phase 230-volt power. It still ran PathPilot. It still allowed buyers to choose options. That was the personal CNC DNA that remained. What changed was the scale of commitment. The machine weighed about 2,800 pounds, required 30-amp power, and needed more serious space. With an automatic tool changer, probe, coolant system, enclosure, and work holding, the total investment moved into the many tens of thousands of dollars. Buyers were no longer comparing it with a kit. They were comparing it with a Haas mini mill, tool room mills, and compact VMCs. The Haas mini mill uses a 40-taper spindle, has higher published spindle power, and is supported by the Haas factory outlet network. Tormach answers with PathPilot, single-phase power, axis speed, footprint, modularity, and a direct relationship with customers. This is not a one-sided contest. Haas is optimized for production at a higher tier. Tormach is trying to keep engineers, schools, and microfactories inside its ecosystem for longer. The 1500 MX could become a new peak if it helps customers move from prototypes to small batches without changing controls. It could also get trapped if its price sits too close to industrial machines, while its spindle power, mass, and service model fail to meet industrial expectations. A new architecture takes years to prove wear, reliability, support, and resale value. The IMTS demo was only the first day of the exam. That gamble completes the circle. In 2001, Jackson and Korn accepted a slower machine to lower the price. In 2024, an employee-owned Tormach is using higher price and higher complexity to buy back speed, while trying to keep the machine within reach of smaller shops. Tormach was not the first company to build a small CNC machine. It did not invent G-code. It did not replace the machining center. What the company did was more influential than a patent list. It packaged a level of engineering capability, logistics, software, and support into a product that individuals and small organizations could actually buy. Greg Jackson and Ed Korn changed who had permission to begin. Before them, serious CNC usually required the buyer to step into the world of the factory. The PCNC 1100 brought part of that world to the buyer. It did not deliver an entire production system, but it delivered enough capability for an idea to touch metal, for students to learn on real chips, and for a small business to take its first order. That is why Tormach's influence is difficult to measure only by the number of machines sold. No matter how the newer models perform in the long run, the reason they exist is already the clearest legacy of Greg Jackson, Ed Korn, and the PCNC 1100. A machine does not have to replace a factory to change manufacturing. Sometimes, it only has to shorten the distance between a person with an idea and the first usable part enough for that person to build everything that comes next. If you enjoyed this video, like, subscribe to the Gear Archive, and leave a comment with your thoughts. Thanks for watching, and I'll see you in the next one.